Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.fm radio. It is Friday evening. It is the very first Friday of 2019.
It's the new year, everybody.
It is January the 4th, 2019, about 9 o'clock in the evening for those of us here in the eastern portion of North America. Universal time, that put Saturday morning, 2 o'clock in the morning. Again, January 5th, 2019, our first show of the year. And don't forget, go to the homepage, find the chat room, join us in chat. So far we got me and you, Nick.
By Saturday morning, US time, or certainly by Saturday afternoon, you can go to the AFM Facebook page. You can go to my Facebook page, and you can actually get the YouTube version of tonight's show, complete with all the links, which are being dutifully gathered by Starstorm tonight. Hello, Starstorm.
Hovering in the background.
Yes, she's actually listening. She got a nice laptop for Christmas.
All right.
She is now actually able to get away from being in the same room as me. Mm-hmm. She can actually listen to the show. Mm-hmm. And she can also, she can send me messages. Now, before we go any further, Marty. Right. I have been asked by Michael Forrester to make the following announcements. There will be more coverage of the New Horizons at Ultima Thule in 1 hour after the end of Event Horizon. So you got First Light, then you have the Ultima Thule show, and apparently Michael says he's off to see The Wizard. So I'm assuming he's off to see something Oz related. I
thought he was working tonight. Maybe I could be wrong though.
Yeah, but anyway, he's asked us to make sure everybody knows that there will be more coverage of New Horizons at Ultima Thule. Also, it's Ultima Thule, but whatever. So that is 1 hour after the Event Horizon, and there will be a First Light between Event Horizon and Ultima.
Alrighty. Sounds good. Sounds good to me. Well, go ahead.
We're all well aware of Changi 4, and my little rant is about this thing everybody has about saying the dark side of the moon.
Ah, yes.
The Dark Side of the Moon is an album by Pink Floyd. It's a very good album by Pink Floyd.
Well, it is also half of the moon.
But it is technically incorrect. The correct way to describe the other half of the moon we don't see is the far side.
Yes.
Now, yes, the far side is dark. So when we are seeing the phases of the moon, hang on a minute, Marty. So when the sun is lighting up the side of the moon we see, it is dark. When the sun lights up the far side of the moon, the near side is dark, and we have new moon.
Yes. So,
in between the waxing and waning moon will mark where the robots are entering dusk or dawn. Uh-huh. So, obviously, Changi 4, it is a game changer. And I am one who is very, very pleased to see it. The Chinese are doing what they've done. They have launched a satellite and a lander and a probe. Now, what the big game changer is, they are using a satellite to talk to the lander and probe as it tunnels around the far side of the moon
and the Earth,
and they're using a satellite to communicate with the Earth. Mm-hmm. So I've got a link. I've always got a link. Mm-hmm. Okay, yep, we'll get to that in a few seconds, Starstorm. So there we go from The Verge. And of course, the thing is, the moon is dark, But as I say, when we have full moon, the far side is dark. When we have new moon, the far side is lit. So
when we have first or last quarter, half of it's light and half of it's dark.
Exactly.
Both sides.
So using the phrase "the dark side of the moon," if you use it to me, I'm going to think you're talking about heavy rock and Pink Floyd.
Yeah.
Whereas you say the far side of the moon, that means the side of the moon we cannot see because the moon is hardly locked.
There you go.
To us. So there we go. A little correction. If you're going to just talk about the other side of the moon, it's the far side. The dark side is anything to do with Darth Vader, Emperor Palpatine, and or Pink Floyd.
The next space mission there, the dark side will be where the Goth astronauts land.
That could be interesting, yes.
Mm-hmm.
I can already hear Starstorm from the kitchen. She's coming in. She's got something to say about this.
You say dark side of the moon to me, and I think of I'll Make a Man Out of You from Disney.
There you go. So that is Starstorm's point.
Yeah, I think they actually landed. I think they actually landed around sunrise on the backside of the moon.
Very good song.
Now it landed at the von Karman crater in the South Pole Aitken Basin, according to Chinese state media. The basin is a massive 1,550 mile wide impact site that is miles deep and billions of years old.
That's a big one.
It's a big one. Oh yeah, it's definitely a big one. And the U-22 rover is equipped with ground penetrating radar. So not only are they taking some nice photographs of the far side of the moon, they're actually looking beneath the moon's surface. Now, obviously, whilst we wait for it to collect its data, we can enjoy the views it's sending back from the far side, which is right now sunlit.
I think it should be sunlit for if they get there about sunrise, then it's about 2 weeks of daylight before it goes into nighttime.
So anyway,
are they prepared for that, though? I would assume the mission's going to be longer than 2 weeks, right?
Oh, yes.
Is this a nuclear-powered?
From what I can see, it's batteries and it's solar cells. So obviously, they're looking to take. I'm going to assume that there will be downtime when when the moon is waxing and going full and waning to us, and it's deep night is the lunar night on the far side of the moon.
Mm-hmm.
However, having said that, no doubt the Chinese know exactly what they're doing. The first time we ever saw the far side of the moon was 1959, when Luna 3, which was a Soviet spacecraft, took a very grainy photo of the far side's crater-covered landscape.
Mm-hmm.
And one of the things that is interesting, and this is really the game changer, really is NASA wrote off ever having it being technologically feasible to land a rover on the far side of the moon and have it communicate with Earth.
Well,
they even wrote the idea of sending astronauts to the far side because of the lack of being able to communications. They could have done what the Chinese have done. They could have parked the command module at a point where it can see the Earth and it can see the landing site. That would have been feasible. But they decided that the whole idea of astronauts on the far side of the moon was far too risky, and they abandoned the idea, which is understandable. I would hope, perhaps, when we're talking about the new lunar space station, the Gateway project, that they will perhaps finally send astronauts to the far side.
Mm-hmm.
So that would be excellent, because it would give us finally a chance to explore and perhaps find out a lot more about the lunar crust composition. Keep in mind, during the late lunar bombardment, the moon was heavily cratered, but most of the craters are on the far side because that was the side facing out into space, and that's what took the main impacts.
Well, I think the main impacts were probably on what is now the inside, the Earth side, those are, I think, the main impacts, because that's where the mass cons are, mass concentrations. And I think that's what tidally locked this side to the side facing the Earth. So I think the heavy bombardment, the really big stuff, is basically put more weight on our side, and then it eventually just kind of stabilized so that the side that's basically heavier was facing towards the Earth, and the side that was facing away from the Earth no longer had those big ones, which wiped out a lot of small craters. So the far side kept accumulating small craters. It was early on. It was the big stuff that was colliding, and then the small stuff after that. So the big stuff, twisted around so that the far side got exposed to more debris, and that would kind of make more sense that way too.
Now, Cassie has asked a question: why the different color photographs of the moon from China? I think the images that we're seeing from China News, the main one is obviously from the actual lander, and the other two little ones are obviously the descent pictures. So obviously on the actual lander during descent it was in black and white, and now that they landed and they're actually beginning to move around on the lunar surface, they're able to take color photographs. To be honest, I don't think they would waste color imagery on the descent stage of the mission, but obviously they're also maybe going to be looking at images in different spectral wavelengths to determine mineral content. If you look at some of the pictures of the moon put out by the Lunar and Planetary Institute, they use different colors to show different chemical elements in the lunar regolith. So I think this is what we're going to.
Yeah, I'd take a look at them too, because I want to see what the shadowing looks like. So if they landed somewhere around sunrise, they should have some pretty long shadows, which will not give you as bright of a ground as if the sun was higher in the sky. Like now, the sun was not like at noontime when the Apollo astronauts there. That was it was too hot. The ground was too hot, so they did about a 45-degree angle from first quarter, something like that. So I wonder if those images will have some pretty. I haven't seen them in a while. Some pretty long shadows, which will give you less light on the ground, which could make them look a little bit more warmer colored.
Yeah. Now, Starstorm is saying too much dust on the descent for color pictures. I would believe so. The point of the camera during the descent stage is to give the main mission. Let's call it main mission. Okay, I'm borrowing it from Space 1999. Who cares?
Sure.
Gordon's alive, I tell you.
There you go.
But to be honest, when you're using a camera for descent, you really want the best possible sharpness and definition, and that is something that black and white that monochrome does really give you. That is why a lot of astro imagers will often produce a luminance only image, because using the luminance filters which is basically a clear filter anyway, you can see a lot more detail. Yes, using the combination of red, green and blue filters does give you a better idea of color from the object when you're imaging astronomically, but luminance will provide an awful lot of detail. And I think on descent, this was the important thing. For that, they need detail. They needed to see exactly what the terrain was like, give them a better appreciation of where the probe stood as it came in.
I wonder what the cameras were like, because most astronomical cameras are black and white cameras, and they have a filter wheel in front of it, so it'll throw a green filter, a red filter, a blue filter, and then no filter on the image. I kind of doubt they would have that on a lander, because it's too much mechanism to do that. So
it would be a one-shot color system.
So one-shot color is basically each pixel has a filter on each pixel. One pixel will be green, one pixel will be red, one pixel will be blue, and maybe they've got one that's also clear. So actually, shooting it in black and white, if they had a no-filtered pixel, that means you'd have reduced amount of pixels, a little less resolution, but you'd be able to process it a lot faster. So if you're only processing 1 out of 10 pixels, it's going to download and upload very, very quickly that way. So I'm thinking maybe that's what they did. Maybe they just used the pixels with no filters on them, because there was less of them, and that gave them a quicker image that way.
It also allowed them to, because just when you've got just a luminance or a monochrome image, it is much faster to upload and downlink into your control systems back on Earth. You've got to remember there is a time lag in these signals. So by
couple seconds,
a couple of seconds, which can be critical in the landing phase. So by doing this, you're giving your ground controllers much more active on the spot imaging. Now, the lander features the landing camera. Hang on, our producer Rob has just put up some information. I'm just trying to pull that up for us. Just bear with me for 1 second. I changed screens. Okay, so the lander features the landing camera, the terrain camera, the low frequency spectrometer, and the lunar lander neutrons and dosimeter, which was provided by Germany. The rover has a panoramic camera, the lunar penetrating radar, the visible and near infrared imaging spectrometer, and an advanced small analyzer for neutrals, which Sweden contributed. So this isn't really just an all-China project. This is an international project. You've got the Germans and the Swedes involved as well. And to be honest, this, if anything at all, this just shows you how China has come along. Yes, they've gone from in one generation to a high-tech state, but they have taken the lead by making this a multinational mission. Obviously, yes, there's people out there who say, well, it's a propaganda coup. Well, there is a lot to say for that, but nobody owns the moon. There is an international law which I believe the US signed that states space is not ownable by one nation. It is there for the use of all. Now, the important thing to remember is by combining and making this a multinational product, no one country has to worry about having an unbearable debt or demand for resources. And if we're going to go to Mars, if we're going to go further into the solar system, even more so as a manned mission, this is something we have to develop. We have the collaborations with Roscoff, with JAXA, on the ISS, and with NASA and with ESA already. But if we're really going to explore the solar system and really, for want of a better phrase, put it to good use, we have to climb above nationalism. Space, yes, everybody talks about we're going to conquer space. We're going to conquer it as a planet. Now, somebody's going to say, oh, Nick's being a libertine lefty. Well, I don't care. Because at the end of the day, in order for us to explore the solar system in a proper scientific manner, it can't be done by one nation. When you think about the cost of going to the moon originally with Apollo, it took us through the Mercury, we then went to Gemini, and then finally Apollo. Apollo led on to the space shuttle and the ISS, which is an international collaboration. Now, politics aside, the only way you can explore the solar system and hopefully make the jump to outside of the solar system with advances in technology and science is to do it not as a nation, but as a planet. Or maybe, I know everybody knows, nobody likes the UN, everybody gripes about it. It doesn't have to be the UN. Countries can get together, they can agree what they're going to contribute in training, in materials, in science, in production. Globally, we have the ability as a species to go forth and explore the solar system. And I think that is the only way we're going to do it. We're going to have to put aside petty national issues. We're just going to have to grasp the nettle and say, we want to do this, we're going to do this, and we're going to do it as a group. And the thing is, we've proven with the ISS already that nations who don't like each other can work together. Global is the best, Cassie. I totally agree, and I agree, Starstorm. Cooperation is the key.
It is, unless somebody gets an overwhelmingly amount of resources.
Well, the thing is,
then the game changes.
But so no one can afford to
start
alone.
Well, if one country can get a tremendous amount of resources, valuable resources, they could go it alone, and that's happened quite a bit. So it's just a matter of not only the politics, but how the resources are distributed. Everybody's interacting right now with resources, but if somebody came upon a free, almost ultimate energy source in their country, it will get very rarely distributed around, and it'll be kept pretty much in check as much as possible.
I know it's a sad thing. I really hope. I would like to see united federations of planets eventually. I like the idea of everybody cooperating together for the common good. Yes, Starstorm, why not? We need a Tony Stark. We need the arc reactor. But as I say, cooperation is the key to exploring the solar system. It is the key to going beyond the solar system, to stop being a species locked in either low Earth orbit or the inner solar system. If we want to get out there, at the moment we're going to have to think generation ships. We're going to have to work together to find a workable suspended animation technology, and so we can send out our astronauts, taikonauts, cosmonauts, whatever nauts out to explore. At the end of the day, today it cannot be afforded. No one country. If we had to do Apollo today, I do not see it happening, because the money is not simply there anymore, and neither is the will to get off their butts and do it.
We'll see. See how it goes. By the way, speaking of space aliens out there, any Green Orion dancing women? Call me.
Be careful, Marty. You might get into trouble. Now, let's go for it. Should we segue into the constellations of January very, very quickly?
Okay. I want to do one. What were we just talking? Oh, we're talking about the mission back in the moon. Okay, we haven't done that much on Ultima Thule, though, so we'll get back to that.
That's lined up. Don't worry. I haven't forgotten it.
I actually have the positional coordinates of that, which it took me a while to find.
Yeah.
But so we'll go
First
ahead and
start to the right and a little bit further on.
There you go. Hang a left at Pluto.
Yeah. So anyway, what are the constellations of January? So we have the Sculptor's Chisel, Stellarium, Dolfino the dolphin fish, Mensa the table mountain. Of course, Orion is still dominating our skies, Reticulum the reticule, and Taurus the bull. So there is still a very rich almost a winter sky still out there for people to go and enjoy. Learn to star hop. Get a star map. Get a planisphere. Learn your way around the constellations, because this is how you discover things like comets, novae, and supernovae. Because you know that something's wrong with that constellation. There's something there that shouldn't be there, and that's when you get onto the internet. You make a report to the Minor Planets Center, to the IAU, and if you're lucky and you're the first person in there with a proper report, your name's on it. Mm-hmm. Your name goes down in history. That is how the game is played. Now, I happen to know that one of my friends on Facebook has actually had his fourth supernovae. Just 1 second. I'm just going to quickly pull him up.
Another supernova?
Yep, just 1 second.
Really? Oh. I was looking on the reports for that, and I didn't see anything listed. Is it, well, depending on how bright it is, the reports I get are 13 and up, so if it was much dimmer than that, it might not show.
Pai Yen Sun in China, he manages the Corona Borealis Observatory. He comes from Beijing, China, and he has now chalked up his fourth supernovae. It is SN 2018, and it's MGC 1-5-42, and that was discovered on December the 31st of last year.
Okay.
There's a Type 2, and it's numbered as SN 2018 LCD. And I actually have a link here. Ooh, aren't I lucky?
I think that was a fainter one, about 16th magnitude, if I recall.
It was a very faint one. But no, it doesn't matter. It's been discovered, and he has his name against it. There you go.
Oh, yeah, I'm just talking about is how visible it is to most amateur astronomers.
17th magnitude.
All right, at Discovery Point.
Yes.
Okay, yeah. So not when a general amateur astronomer can go out and point your telescope and look at visually.
Well, if you've got a decent CCD and you've got a light bulb, you can do it.
Or just use the iTelescope network.
Yep, you could probably do it on our telescope very easily, given some of the size of their light buckets.
Do you have the constellation of this object?
Let's have a look. Let me see what I can find here.
All right.
Because it's given
the general RA and deck. I can.
Okay, I've got RA and deck for you. It's 1.5110.810 minus 032926.87.
All right, stretch it slowly back. What's the hours?
Yeah, 0151
01
10
All right, so about 1 hour. All right, 1 hour, and the first two digits of the declination.
Minus 3.29.
Minus 3. All right, I'll go look that up on Stellarium here real quick and see if I can figure out where that's at. So. About where am I? All right.
Alpha Myriad, Starstorm says, laughing.
2 hours, 1 hour, and let's see. Mars is at.
Let's go into Sinbad.
Minus 3. It's actually kind of close to Mars, it looks like.
Yeah, it's in MGC 01050442. That's the galaxy it's in.
It doesn't sound like an NGC number to me, though.
Okay, so I'm just trying to see if there's any other information.
Minus 3. Well, let's see. Mars is at approximately declination of about 1, and our angle of about 0, so it's somewhere around Mars. Mars is in Pisces, by the way, so somewhere around Pisces, where this thing should be.
Yeah, but it's very interesting. Anyway, you can go on to Visor, Aladdin, Sinbad, X-Match, etc., and pull up all the lovely details. In fact, there is actually.
There is what?
There's an image on the Visor on the Sinbad page.
Okay.
Let me just pull that up.
Okay. Supernova 2018 LCD.
There you go.
Okay.
So that is the Sinbad link.
Okay. And 2018 LCD. Got that. I've got another website which is good for that information. It's from the Rockland Astronomy Club. They put out all the information on the latest bright object discoveries. Rochester. So you could type in the words Rochester, ROCHESTER, astronomy.org. And that should get you to their supernova page. Well, you should be able to find their supernova page after that. And so they publish them all out from brightest to dimmest and by date too a little bit. So come across that, and I'll see if I'll give it a quick look here. And I got to scroll down quite a bit because it was a little while ago, but I'll see if I can find it while in.
Okay, shall we do a station ident? It's about that time.
Is it about that time? You want to do a station identification, and I will look up, see if I can find the supernova.
So it is 02:28 hours GMT, 9:28 p.m. in the Eastern Time Zone, and you're listening to the Event Horizon on astronomy.fm. Now, let's go to Ultima Thule.
All right, we'll go there.
Because the hunt is on for moons around Ultima Thule.
Mm-hmm.
They think it may have moons. Now, okay, first thing on the time I saw this, I thought, hello, we've got another CG here. We've got another rubber duck. But no, it's not a rubber duck. It's a snowman. It's a contact. Having said that, CG, it is a contact binary. Mm-hmm. And, of course, this one is more snowman-shaped. But it is interesting because it shows you how different the contact binaries are. Now, obviously, this is so pristine, it's never, ever been contaminated. It hasn't been perturbed out into the inner solar system. So there's a lot of pristine materials here from the beginnings of the solar system. So, yeah, I think we've got to go back. It's a long trip to Ultima Thule, but we proved we can do it. Not only has New Horizons amazed us and thrilled us with Pluto, now... yeah, okay, flattened rubber duck, I suppose. If you're not in the chat room, you're missing half of the fun. Because you're missing everybody's comments, you're missing the questions, and you're missing the chance to poke fun at me and Marty.
There you go.
Then today, I think that's the greatest thing about being here live, is you can come into chat, you can take part in the show, and you can have a good time. And you can look at the links. The links will be available, as I said at the beginning of the show, on the YouTube video, which will be I will post as a very public post on Facebook. So you just search me or search astronomy.fm on Facebook, and the links will be there for you to listen to the show and read all the links. Pardon? Yeah, you got a good point there, Starstorm. We make fun of ourselves, don't we, Marty?
We do.
So anyway.
Or of each other.
Yeah. So in the small wee hours of January the 1st, New Year's Day, New Horizons zoomed past small, frigid Ultima Thule. It's more than 4 billion miles. That's 6.4 billion kilometers from the Earth. It's beamed home just a tiny fraction of its flyby data so far. But the team members are already beginning to get the goods on the far-flung rock. For example, they now know that the 21-mile-long Ultima Thule is composed of two roughly spherical lobes, which apparently began their lives as independent, free-flying objects. They started spiraling together, and like gravity does to you, you get closer and closer. It's a fatal attraction, and it joined up in the solar system's earliest days to form a reddish snowman.
Very slowly too.
Very slowly, yes, but that's the whole thing. Far out in the solar system, gravity takes a little bit of time to get its act together and assert itself, but eventually it always wins.
Well, they're pretty small objects, maybe like 8 miles in diameter and 10 miles in diameter, something like that. So each object does not have much gravity on its own, no matter where it is in the universe. So yeah, they kind of went together slowly and just kept sticking together. So it definitely was not a crash. It's kind of like combining two snowballs together.
It's kind of like two neutron stars, really.
Two what?
Say, two neutron stars spiraling around their common point of gravity until they virtually merge. Happy New Year, Red Shirt 3.
I don't know if I would say there's not enough gravity probably for them to spiral around each other. So it's probably just a gentle collision. Like I said, think of two snowballs combining together so they both stick together. Not enough force to crush either snowball during the collisions, because they would have busted up and just formed one object that way. So pretty gentle contact between the two of them. A little bit of rotation there, not much between the two. So didn't sound like it was rotating very fast when they came together.
Well, they're talking about a rotation initially of about 3 to 4 hours about the time they hooked up together. Mm-hmm. Present day Ultima Thule takes about 15 hours to make a full spin. Now, thinking about this, we remember, of course, the biggest conundrum that we had, because we couldn't figure out the albedo.
Yeah.
Now we know why. Now we have the answer to that question. Why is the albedo so low, so far out? Because it's two bodies, and they're taking about 15 hours to make a full rotation, a full spin.
Well, plus they're much smaller than they first. I was wondering when they first thought of it. I wonder if the albedo is actually brighter than what they thought, because judging by the brightness of this object, from the Earth it looked like it was about 26 magnitude, which is really, really dim. But they figured with the brightness of the thing, it must be about 500 miles in diameter. Well, it turns out it's only maybe 10 to 20 miles in diameter. So that means it's actually a lot brighter than it was expected, because being brighter implied that it was a bigger object made out of dimmer materials. So it's just kind of the reverse. It's small but relatively bright to make it appear to be bigger on their first analysis of it.
Now, the mission team has ruled out any sizable moons, at least 500 miles or within 100 miles of the object. Showalter said that the middle zone is a big question mark and will remain so until late January, when more data is beamed home from New Horizons covering the region. And crucially, that in-between zone is the most likely places for satellites to exist. We know this happens. We know that having a satellite is a very common affair for dwarf and minor planets and other asteroids. So why shouldn't Ultima Thule have its own moons? Pluto has them, which was so.
The farther out you get, though, the less stuff there is, just by being in a larger area. So less chance of attracting another smaller body and keeping it gravitationally attracted, because so small a gravity, these two objects together.
The thing is, moons as a braking satellites carry away angular momentum from their systems, central bodies. So those moons probably have moved further and further out into space. So it probably once did have such satellites, but they're now perhaps so far away that they're eventually lost. Now, Redshirt 3 points out that he thinks he heard that the reflectivity varies from about 3% to 13%. And I agree, that is pretty dark. When you're considering that you've probably got at that probably still is a very cutting edge charge coupled device looking at the object.
Yeah, I can't remember what the moon is, the reflectivity of the moon material. It seemed to me it was right around those numbers too, if I'm not mistaken. To give you an idea what that reflectivity is like, is basically like asphalt in daylight.
Yeah.
You know, with the sun shining right on, kind of glaring in your eyes, it looks a lot brighter than as dark as it actually is.
So, as I say, it is something that is still really going on and is really going to keep us going. And to be honest, if they've got the fuel, I think they should go to another one. They should find another Kuiper Belt object that would be reasonable to get to, go visit it, and do the science again. Because the more we look at these objects, the more we actually have in the form of data to talk, so we can start thinking about perhaps a new model of solar system formation.
The farther out they get, though, the harder they are to discover from the Earth.
Oh, yeah, absolutely. And that's probably something they can actually look for, something they already know about that may be slightly further out and use it as a third target. But I think really at the end of the day, it's down to how much fuel New Horizons has left and what power it has left. But as I say, we know the radio transmitter's in good shape. It's talking to us continuously. The DSN is receiving it. It is transferring the data into the computers. Excuse me. And we're getting the images back. And that perhaps is the most important thing. They call Pluto a dwarf planet. I am sorry. It is still one of the original 9 to me. It always is going to be. I was brought up on it as being the 9th planet.
Well, you might want to consider Ceres, too. That was originally considered a planet, too.
Yeah. So we've got 10 planets.
Might have to keep that planet as planet then. Yeah, so that's a possibility. I did a little calculations on New Horizons. It was flying by at about 31,000 miles an hour, something like that. So passing by an object that's only about 20 miles across, traveling at 8 miles per second, it basically was at its closest point to Ultima Thule for about 2 seconds.
Yeah.
So and they were about 2,000 miles away. And I think if they knew how small it was, they could have actually probably closed that gap by 90% and flown by at about 200 miles away, compared to a 20-mile diameter object. That wouldn't have been so bad. But I think because they considered it to be about 500 miles. Yeah. 2,000 miles away that they were from the object was made a big difference. So they would have gotten better, closer images by if they really knew what the size it was, because they could have been closer to it. But 2 seconds to fly by an object like that's not much time. You don't get very many pictures that way, let alone the other data you got to collect too. So that's a quick one to fly by.
Now I skipped to the bottom of the article. Yes, Ultima Thule is the centerpiece of the extended mission, which runs through 2021. The spacecraft does have enough power and fuel and is in good enough health to potentially fly past a third object, but that is down to NASA to grant another mission extension, according to team members.
Okay, cool.
So this is the little space probe that gives and gives. It's like the Energizer Bunny. Come on.
Well,
it gives, it gives, it gives.
As long as it's got something to look at. That's the thing. Yep. So hopefully it will.
It would be nice because if anything else, it can give us an even better idea of just how deep the Kuiper belt or the Oort cloud / Kuiper belt, I suppose, if you're going to be really fair, is, and perhaps give us a better idea of its composition. Because eventually, if we do get the capability of leaving the solar system on manned ships, we really do need to know what we're facing. Is it a disk of material, or is it a halo around the solar system? This is to me is one of the most intriguing questions about the Kuiper Oort belt. Is it like the asteroid belt, something that you can technically jump over, or is it going to be something that it completely encompasses the solar system as a shell? Now we know how far
the Oort cloud does, but not the Kuiper belt.
Yeah, but as I say, this is something perhaps New Horizons can do. It can expand our knowledge of the Kuiper belt, and if it's still able to talk to home and phone home, maybe it can be given a tertiary mission of determining the actual limits of the Kuiper belt.
I wonder if it'll change the size estimates of other objects out there in the Kuiper belt.
I think it will, because basically, even with the Hubble, we have very, very pixelated images. They're not very we can't determine to a greater degree the actual size of the objects.
Right.
New Horizons is in a position where it can.
Well, and obviously it determined Ultima Thule its size and brightness, which they said they downgraded the size of it when they actually flew by it or got close enough to it. So I wonder if they're going to start downgrading the sizes of some of the other Kuiper belt objects that they think might be a few hundred miles in diameter, and it turns out they might only be tens of miles in diameter.
And keep in mind that the Oort cloud, and to some degree the Kuiper belt, is the reservoir for an awful lot of comets. This is where they actually reside until one of the outer gas giants perturbs them enough to bring them into the solar system, where either they're going to get captured and join the Jupiter family, or maybe they'll go through the solar system, give us a cracking good display, go through perihelion and come out the other side with luck, touch wood, and then perhaps even go back out to the outer solar system and maybe even escape the solar system itself. So as I say, this is another important thing we need to know about the composition of the Kuiper belt and the Oort cloud, because there's an awful lot of stuff out there. We may be able to, eventually, when our technology gets to the point, we could take advantage of for perhaps looking at the number of water-bearing comets or the actual amount of water on rocks out there, just sitting waiting to be either kicked into the solar system to stun us, or with a display, or to provide water for perhaps the terraforming of perhaps even Mars.
Or we go out there, grab them, and fight over them.
I think there's always going to be that risk. Industrialists don't care about laws, about rules. It's, I want this is mine, I'm keeping it, get away from my claim. Yep.
So much from the neutrality of space.
But the thing is, neutrality of space is a accepted legal point between nations. Until
it comes to money.
Well, maybe we'll get over that as well eventually.
Maybe, yeah.
Okay. Maybe I'm really hoping that we're going to get the Jim Kirk universe, where money isn't really all that important.
Wait. Star Trek's got all kinds of fighting over stuff.
Yeah, but that's really...
It's not an ideal situation. You got your Federation, and you got all the other local power-hungry planetary associations that are fighting for resources amongst each other. It still happens.
But
even in fantasy, it's still happening. So.
It still happens in science fiction. But the idea of a federation of species where everybody wants to work together for mutual good, Is
really the Klingons on a bad day?
I'm getting Klingon comments from Starstorm. But the thing is, at the end of the day, if people are willing to get together to work for mutual goals where everybody is happy, but
you still got admirals and you still got red shirts going down, security people in red shirts. So it's like, it's not equal. It's all equal, but some people are more equal. Some people are more equal than others. So
there's always two red shirts that never die.
That's right.
Scotty and Uhura.
That's right. Let's do one comment. 64p.
64p, yes.
Let me put that into our chat room here. So it's the next semi-brightest comet. It's not that great. It's just okay. A little bit bigger, a little bit dimmer than 41 Wurtinen.
46.
46. Yeah, that's what it was. Okay, but it's out there. 64. It's actually going to be passing by the Pleiades, but instead of south of the Pleiades, it's going to be going by north of the Pleiades. And here's the map. It's just going to be in a few more weeks. It'll pass just north of the Pleiades. Reported, I think, around 9th magnitude, something like that. So kind of dim. You have to have a fairly bigger scope and some super dark skies if you want to see a 9th magnitude comet. I've tried for some of them, and they've been actually too dim for me to see sometimes. So.
There you go, Marty.
You got some, where you got that?
That's my image of 64p Swift
64p. All right. And how long ago was that? There you go.
That was taken on the 2nd of January of this year.
2 days ago. Okay.
2 days ago.
All right. So it's still out there. Well, obviously it's out there because Pleiades are well prominent in the skies right now. So let's say it's going to go across the Pleiades, north of the Pleiades, a few degrees. So well placed or easy to find.
I wish it would go across the Pleiades.
That would be nice, yes. But might be too dim for most people unless you got big scope and dark skies. Give it a shot, though.
Since we're talking comets, there's one that I have been really killing myself to get, and I finally got it. It is C2018 Y1 Ayamoto.
Oh, yes. I've been hearing about that one. Not a really bright one.
No, it isn't.
But in some reasonable skies, though, as far as altitude and latitude, longitude, stuff like that in the Earth.
This I took via a telescope in Chile, in La Densa.
Okay.
And as I say, it is. You can see it. It's pretty much just off center of the picture. It is a very, very faint comet, but it is there. Now that was taken with a 14-inch SCT, with an S big CCD on it. This
altitude, brightness magnitude is estimated about 12 to 13 magnitude, something like that.
Yeah.
And I show it somewhere around between south of Spica, which is.
And you know what's really interesting is very few of the websites have got it listed really? At the moment. I mean, going into not Skynet. I don't want Skynet. The Sky Live.
Okay. I'll put this link with the chart in our chat room here. There you go. It's from Chasing Comets, I think it is.
Yeah.
So check that out.
In fact, the Sky Live, as of this moment, it's finally listed.
Okay.
Oh my good grief! It's finally listed.
Because
I had a real
new discovery.
Nightmare with this. Yeah, I had a real nightmare getting this one. So as I say, you can. This gives you a chart against prominent stars, where you can actually see it, and that is set at the moment. What's the time on this? Because I've got. Come on.
Well, I put the star chart into our chat room there for people too. Yeah.
Yeah. So as I say, it's at 14 hours 13 minutes, 2.5 seconds, and minus 23, 36, 13.5 declination. That's J2000. And it's magnitude 10.7, according to Cobbs. It's a reserved comet.
Okay.
Magnitude 10.7.
Yeah, count on it being dimmer than that, though.
So I say
like most
it
comets.
is there. Yeah. But that's the fun thing about imaging comets, and I think some degree, if you're an observer to looking for comets, it takes a lot of work. Now, obviously, I got lucky. It was It was very easy to pick out on the image, but it really takes, as an observer, eyeball Mark 1 and a telescope, a lot more work to find it, because it is very faint, it is very diffuse, and it is a very, very small, faint, fuzzy patch.
Yep.
Interesting nebula. Yes, there's plenty of interesting nebula out there too.
I'm showing it just east of the constellation called Corvus, south of Spica, and about almost 7 o'clock in the morning, pretty much on the meridian.
Yeah.
Obviously a better object for Southern Hemisphere observers, because Northern Hemisphere observers got it pretty low to the southern horizon. Well, we got a nice Venus and Jupiter coming up after that too.
True. But as I say, I think for Northern observers at the moment, this is one we're going to have to really hope comes north. If not, go across the to eye telescope and wait. It will. I haven't seen it yet available that side. I think one guy has used Siding Springs or Bathurst to get it. I had to go and use Chile to do it, but you know what? I still had an awful lot of fun getting this image. I didn't sleep properly because I was waiting for the email to say, Nick, here is your imaging run, and then I grabbed it, opened it up, pulled up the picture. Yes, I got you, my son.
I thought I put this link to it in our chat room, but I don't see it there. Did it not go?
Only got the Sky Live one for that comment for Y1.
Okay, I thought I put a map in there, but I will check it again. Oh, it would probably help if I actually entered it.
Yeah.
I put it in the bar, but not actually. All right, it's going to go up. Yes, it's definitely heading north from just south of Spica. It's going to head up through Virgo, through Leo, pass a little bit north of Regulus, and that would be right around the first week of February, so it's a quick mover. And then after that, from Leo, it's going to go into Cancer, Gemini, and Auriga, so definitely heading north. But I'm sure that means it's getting a little farther out, too.
Yeah,
so
now
make it get dimmer as it goes that way. So
the other thing I've had brought to my attention, since we're talking comets, is 29P. My old nemesis, Schwarzman, whatever. SW1, okay. Not Southwest, London Southwest one either. Now, the image I'm looking at, unfortunately, I can't share it. It's a Facebook image.
Okay.
But as of November 26th of last year, 29P was in outburst again, or beginning to dim after an outburst.
Okay.
Again, my friend P. Yan Sun at the Corona Borealis Observatory, MPC code N55, managed to image it, and he got a lovely image with a galaxy on the left-hand side of the picture. A very nice double fried egg job.
Nice.
It looks like he had a zoomer there as well. So, yeah, looking at it, I think SW1 was definitely an outburst. Mm-hmm. And this is one that's it's a Jupiter family comet, and this is a regular outburster. And this one was imaged on a 0.3 meter f7.2 reflector at 20 by 40s clear, according to the picture notes.
Okay.
So, as I say, plenty of things you can do. And everybody, there's no bright comets. Well, you know what? Big deal. There's plenty of other comets. All the comets we know about still need follow-ups. They need to be tracked. They need to be imaged as they head in and head out of the inner solar system. Certainly with SW1, this is an outburster. I know quite a few of my friends would love to have a New Horizons style space probe or even a Rosetta mission to hit to this, because every now and again something triggers it into outburst. It doesn't come into the inner solar system.
Been a fair amount of outbursters out there, actually.
There are, yeah.
Surprisingly,
yeah.
It's kind of a rare thing in the past, but now it seems to be a bit more common. At least I'm hearing more about them, anyways.
Well, yeah, because as I say, the amateur instruments are as good as the professionals, and as I say on a regular basis, we have the greatest possible thing. We have unlimited time on our telescopes. The professionals have to go on a program where they pay and have a dedicated program to follow. They may get 2 or 3 hours, maybe in a month, where they can image. We go out, if it's clear, night after night after night. We can image these comets. We can do spectroscopy. We can do photometry. We can literally do the things that the professionals would love to do every night of the week. If we could
stay inside and look at pictures on the computer too.
We can be in the nice warm living room, bedroom, or radio shack. We can be looking at our computer monitors as the photons are collected and processed by our computers.
Or just wait till somebody else takes a picture of it and posts it online somewhere.
That's boring, because I want to take images. I am working to the point where my images are considered scientific data, because by telling what you do is you have to give every piece of information about your kit. You tell them the telescope, all the specs of the scope, you give the specs of the type and specs of the camera. For the heck of it, on one post I did in a comic group, I actually put the ACP log for the imaging run. Now, the nice thing about our telescope is you get your image, you get all the weather station stuff, you get an all-sky picture, and you get a copy of the imaging log for your run. And I put that up. I was feeling kind of naughty at the time, and I thought, well, what the heck? Everybody complains, oh, we've got to have more data. You want data? Here's the data. It tells you how long the camera was imaging, how long it was slewing, about guiding. Everything's there. And that is important information to a professional scientist. He may be looking at your image 10, 15, 20 years down the road. But because you have given imaging information on the telescope, on the camera, on the weather, he can take that image and do good science with it. That is the important thing. Anybody can take a pretty picture. But
not anybody.
But the thing is, Marty, to take a scientifically useful picture or image, you must back it up with data about your telescope, your camera, the weather, everything like that, seeing conditions, because that all affects the results. And at the end of the day, having that information 10, 15, 20 years down the road, it tells the guy in the lab or even at the desk what the conditions were, what it was used, how it was imaged. Even processing information can be great. And even if you supply raw image details and your darks and your flats, by giving all that information over, when you post into the science groups on Facebook, or if you go to the University of Maryland, to their collaborative, where they're collecting images of comets, asteroids, and everything, every piece of information you have about how it was taken and how it was treated tells the person who may be using that picture later, that image later, exactly more than, oh, it's just, okay, so it's an odd-shaped comet. But now he's got...
We're running out of time here, so keep going, but make it quick, because we got a couple things to do.
Yeah, I know, we're down to 2 minutes.
Yeah, or less.
Said Nebula, still cracking along, still being a stellar nursery.
Yep, we got some aurora come this way because of the solar winds are pretty dense at 15 protons per cubic centimeter. So there's this hole in the sun's atmosphere letting that through. Got a little bit of a solar eclipse, but you have to live somewhere in the high northern Pacific in order to be able to catch it. Closer to the pole would be better, near the Pacific.
And I've been told by my good friend Black Project there's a major geomagnetic storm going on, and Iceland is utterly and totally clouded out.
Too bad. Yep, I believe it though. Yep, that's what's happening right now. All right, everybody.
Marty,
it's about that time.
This is the away team to Captain Savick. 3 to beam aboard. Hey everybody, been great being here. Great to be back in the new year, and clear skies.
Thanks everybody. Really appreciate it. Appreciate everybody that's been in our chat room tonight, and all of you listening in. Don't forget we got more programming coming up. So
and don't forget,
tuned, everyone.
Ultima Thule after the show.
We're out of here.
First light.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing. And all of a sudden, wham! Astronomy right between the eyes.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.